Alright, so we're going to be graphing a secant graph with the equation y equals 2 secant times 3x minus 6 pi plus 2. Before we do anything, we're going to rewrite it, and it's going to look like y equals 2 secant times 3 times x minus 6 pi over 3 plus 2. So to find our a, we're going to look at the number in front of secant, which we see is 2. And to find amplitude, we take the absolute value of our a, which is 2. To find b, we look at what we factored out, which was the 3. So b equals 3, and to find period, it's 2 pi over the absolute value of 3, which is 2 pi over 3. To find our h, we look at our when we took out that 3, it goes under what we transformed, so it's 6 pi over 3. It was minus 6 pi over 3, but we flipped the sign, and we're going to simplify it, and that is 2 pi. And our k is what's at the end, which is a 2.
Alright, so in order to graph a secant graph, you're going to need to graph 2 periods, which is equivalent to 9 different tick marks on the graph. You already know your first tick mark because you always start the graph at your h value, which in this case is 2 pi. Next, you're going to have to find your width mark so you know how much space is in between each tick. So you'll take your period and you'll multiply that by 1/4, which is 2 pi times 1/4. And in this case, when you're inputting 2 pi into the calculator, instead of writing pi, you're going to input 1 instead, and then in your final answer, you'll bring the pi back, and this will allow your answers to be very accurate. So this gives our width mark to be pi over 6, which is how much space is in between each tick. So next, you'll take your first point, which is 2 pi, and you'll add that pi over 6, which will give you 13 pi over 6. Next, you'll take 13 pi over 6 and add it to pi over 6, and you'll get 7 pi over 3. Then you'll take 7 pi over 3 and add it to pi over 6, which will give you 5 pi over 2. This 5 pi over 2, then you'll take the 5 pi over 2 and you will add pi over 6 to it, which will give you 8 pi over 3. Then you'll take your 8 pi over 3, add pi over 6, and you'll get 17 pi over 6. Then you're going to take your 17 pi over 6, add pi over 6 to it, and you'll get 3 pi. Then you're going to take 3 pi, add pi over 6 to it, and you'll get 19 pi over 6. Then for your final tick mark, 19 pi over 6 plus pi over 6, and you'll get 10 pi over 3. And this is going to be your final tick mark, which will show where your graph is going to end.
Alright, so if you're wanting to find the graph of a given secant equation, what you're first going to need to do is you're going to graph cosine with the given phase shifts, which we did right here. So what we're first going to do is we're going to look at our k value, and that is what is going to give us our sinusoidal axis. So that's how we got this dotted line right here at 2. Next, we can look at our a value, which will give us our amplitude, which basically tells us how far above and below the axis our graph will be going. So if we have an amplitude of 2, we can go 2 up from our axis to reach our max at 4, and then 2 below our axis to get our min at 0. Okay, so next our h value and our period, we already configured where we're going to start and where we're going to end. So for 2 periods of this graph, we would start at 2 pi and then end at 10 pi over 3. So now we can start with our cosine graph. And so since it is a positive a value, we can start at our max, which is 4. Travel down to our axis, down to our minimum, back to our axis, back to our max, axis, min, axis, and then start where or end where we started at our max, right? And so this time I'm actually going to draw in our cosine graph because, as I'll explain in a minute, this will become really important. Down, and then back up again. All right. So, kind of like we did before, all of our zeros on our cosine graph will become asymptotes for our secant graph. So I'm going to go ahead and draw in some little lines to show that our graph cannot touch these. Right, so those are all our asymptotes. Now for a secant graph, everywhere we have a max, like right here at 4, we're going to have a positive or an upwards looking parabola. So I'll show you that. So right here we have a max point. So we're going to have something looking like that, right? And so the opposite is true if you have a minimum. We would have like a downwards or a negative parabola. And so I'll do that for the rest of these. Downward and then upward. All right, and that is our graph for secant.